Calculate the magnitude of the magnetic field at point P due to the current in the wire shown in the figure below. We can calculate the magnetic field at point P by using the Bio-Savart law. The easiest way to apply that law is to divide the wire into three segments. A straight segment on the left, segment 1, a curved segment which is half a circle, segment 2, and the third segment, segment 3, which is again a straight piece of wire. The magnetic field created by all three of them will give us the net magnetic field at point P. So let's start with the first segment. Bio-Savart law tells us that we can calculate the magnetic field created by a path segment using this equation. So what we have to do in order to use the equation is identify the path segment and the unit vector r. Well, the path segment has to be oriented in the same direction as the current. And the unit vector r is oriented in the same direction as the position vector, which is a vector from the path segment to the point P. Therefore, the unit vector r will be oriented in the same direction as the path segment. As you can see, the two vectors are parallel to each other, and we need to evaluate the cross product between them. Well, the magnitude of the cross product between the two vectors will be equal to the magnitude of the first vector, which is dl1, multiplied by the magnitude of the second vector, which is the unit vector r1, which is 1, multiplied by the sine of the angle between them. And the angle between them is 0 degrees because they are parallel to each other, which means that the cross product between these two vectors is 0. If the cross product is 0, it means the magnetic field created by that segment will also be 0. Now let's calculate the magnetic field created by the segment 3. Similarly, the magnetic field will be written using Bio-Savart law. In this case, the path segment dl3 will be oriented to the right in the same direction as the current, and the unit vector r3 will be oriented from the path segment to point P. So the angle between these two vectors is 180 degrees instead of 0. But once again, they are parallel to each other but in opposite directions, which means that when calculating the cross product between the two vectors, you will have the same equation here. Instead of 0 degrees though, you will have 180 degrees. That still gives you a value of 0 for the cross product between the two vectors, which means that the magnetic field created by segment 3 is also 0. How about the magnetic field created by segment 2, which is half of a circle? Well, in that case, the Bio-Savart law is written the same way, and the path segment dl2 is along the current tangent to the circle. The unit vector r2 will be oriented from the path segment to point P, and as you can see in this case, the two vectors are not parallel. They are actually perpendicular to each other. Therefore, I can calculate the magnetic field created by this segment as mu0 I over 4 pi integral of, and the magnitude of the cross product will be the magnitude of the first vector dl2, magnitude of the second, which is 1, multiplied by the sine of the angle between them, which is 90 degrees. And this r represents the distance from the path segment to the point where we calculate the magnetic field, and in this case is nothing else than the radius of this curved segment. So I replaced it with the radius squared here. Sine 90 is 1, and the only thing that I have left under the integral is dl2. Well, when you integrate dl2 over this path, you have to realize that this path is nothing else than half a circle. So the value of this integral will be half the circumference of a circle. The circumference of a circle is 2 pi r, and the value of the integral will be half of it, so the value of the integral is pi times the radius r. As you can see, we can simplify with a pi, and we can simplify with 1r, and we are left with the magnetic field created by this wire at point P equals mu 0 times the current I divided by 4 times the radius r.